What if AI agents didn't just rely on LLMs, but could actually use classic machine learning models as powerful tools? Think about this. You walk into a clinic for a routine checkup. Instead of waiting hours for test results, an AI agent looks at your details like age, glucose levels, and blood pressure, and in seconds it tells you risk of diabetes. Not just a simple yes or no, not just a simple prediction, it actually explains why. Your glucose is normal, your BMI is healthy, your blood pressure is steady, and so on. And then it even gives you personalized health advice like a digital doctor guiding you step by step. This is the power of combining ML models with LLM based agents. The ML model makes the prediction and the LLM transforms it into something understandable, interactive, and valuable. That's exactly the experiment I ran, and the results are very mind blowing. Now, enough theory, let's see it in action. Here's the Streamlit app that I built. We enter the patient details and the ML model generates the prediction. And then the AI agent takes over. The ML model gives the raw intelligence, which is basically a prediction of positive or negative and the probability of the person being diabetic. The LLM adds the reasoning layer to it, turning this prediction into a clear explanation, simplifying the language, and even suggesting practical next step, more of actionable health advice. So instead of just a cold output from a ML model, you get something that feels alive, useful, and actionable. Even you can see the raw tool output if you want more metadata out of it. Okay. And this is what we are going to build in today's video. And honestly, this is just one small example of what's possible when you connect the old world of classic ML with the new world of LLMs and agents. I'm exploring a lot more projects like this, and if that excites you, I'd love to have you in this journey. And right now I notice that most people who watch my videos aren't subscribed yet. So if you enjoy seeing AI experiments that push the limits, please take a moment to hit that like and subscribe to my channel. It really motivates me to keep building and sharing. Okay. So now, if you're curious about taking these ideas further, beyond just this ML LLM combo, I've also built a complete generative AI course on Udemy, and it is like very priced in a affordable way. In this course, we go step by step through building chatbots, RAG pipelines, understand the very basics of generative AI, and so on. So even if you are an absolute beginner, if you just have a basic understanding of machine learning and Python, you can definitely go with this course as I explain generative AI from the very basics. So you would start with creating chatbots and RAG pipelines, as I said, and you would create AI agents and even build with like the state of the art MCP servers, deploy applications with Docker and AWS. And we also have 3 capstone projects right now. So this is the capstone project section. So we have this Convo Pro, which is more of a private chat GPT clone. And there is a study pal. This is more of a study assistant where let's say a 12th grade students can kind of have all their books loaded in the vector database and they can ask any questions from this. So it's kind of a more end-to-end solution that is deployed on the cloud. And then we have the main agentic RAG thing, which we call this as Astra RAG. So this is an agentic RAG chatbot and it is done in a more production grade way. So we have a separate fast API backend, we have a Streamlit front end, and we also have kind of tried to build this in a production grade way and deployed the Streamlit application with the entire backend on AWS EC2 instance. So if you are interested in these stuff, so please check this out. So if you want to level up in generative AI and just start building projects and then just be job ready, check out the link in the description and the pinned comment. So see if this is something that you'd be interested in, and I'll also be adding like more projects as like the weeks go on. So yeah, that is about it. So now, yeah, let's go on to building this use case that we were discussing, which is just combining this amazing AI agent with the machine learning model part. So I'll give the link of this particular code in the video's description. So I'll give a GitHub repository link so you can download it or better clone that repository into your local machine and you can just like work on it. So I'll first explain the project structure. I'll give you an overview of all those codes and all that so that you understand, and I'll also give you the steps so that you can set this up on your own machine. Okay, so that is the entire things that we will follow. Okay. So I also have created a readme.md file just to guide you, but just watch this video throughout because I may have missed a few things here and you also need to understand the code and everything better. So yeah, watch this video and then you can also follow this video code along with this video, or you can also refer to this markdown file and run this scripts as well. So this is what we will be doing over here. So I'll just stop the Streamlit application for now so that we can run the other commands. So I'll stop it. Okay, so I hope you already know to create a PyCharm project and create a virtual environment. If not, you can just search with my name, Siddharthan PyCharm in YouTube. So I've already made a video on how you can set PyCharm and create virtual environments and everything. So you can refer to that. As I said, I already have this GitHub repository cloned. So now let's understand about this code. There are three main pieces to this. So I have all these source codes. So one is machine learning source code, and then we have Streamlit source code, and then agents source code. In the machine learning source code, I have two scripts. One is for training the diabetes model so that we get a pickle file, and then a predict diabetes. This is just for like testing the model. So we would give some input values and get some predictions out of this. So this is the machine learning source code for our project. And then we have a Streamlit source code, which is the user interface that's going to call the agents and everything. And then we have a agent source code. So for agents, we are going to use CrewAI. So CrewAI is like very simple and then like easy to implement if you are a kind of a beginner, and even kind of companies also use this. In the current project that I'm working in the organization, so we also use CrewAI for this current project, so it is also widely used. So you can start with this as well. So this is probably like a simple project, so it shouldn't be hard for you. Okay, so this is the structure. So you have a agent source code folder, and then you have a machine learning source code folder and a Streamlit source code folder. There is a artifacts folder where we are going to save our dataset file and the models, like all the artifacts that we are going to need. So I've just like grouped it in this particular folder so that it's organized. And then I have a config folder. So this is for loading our environment variable. So instead of just like running load.env everywhere, so we are going to kind of follow a more standard approach of using Pydantic settings and all that. I'll explain that code, but yeah, first understand just like the project structure. So you should have like all these folders, with you. Okay, so that's about it. And the first step is to install the required library. So here I've given a command, right? So pip install -r requirements.txt. So here I have a file called as requirements.txt. If you have worked in Python, you already know it. So it's basically a file where we would list all the libraries that we need. So we have like NumPy, Pandas, scikit-learn, which is for machine learning. So we have CrewAI for agent, Streamlit for UI, Pydantic for Pydantic, and Pydantic settings is mainly to kind of handle this in environment variables and just have a better way of kind of defining the settings. And then python.env to load the variables to the environment variables, joblib to save the models. So these are the libraries that we are going to need. So the first step, just go to this readme, or you can just simply type it in. So pip install -r requirements.txt. So I'll copy this command, open my terminal. You can also make sure that the file is there. So you see this requirements.txt is there. So now I can run this. Okay, so make sure you're in the project directory. So I'm currently in this ML powered AI agent project directory. So from this I can run this pip install command and make sure that your virtual environment is activated. Okay, so that it's basically like all the libraries are going to be installed in this environment. Just forgive me if I'm explaining all the basic things, because people who are beginners would also probably be looking at this video. So I just wanted to cover that basic aspects as well. So that's why. So I'll run this pip install -r requirements.txt. So I've already installed it, so it didn't take a lot of time. But when you're running this for the first time, it may take a few minutes depending upon your system specifications and your internet speed as well. So yeah, that's the first step. So now we have to create our .env file. The reason for this .env file is like these are the values that it's going to have. So let me show this to you. So I have a .env file and I have values like grok, API key, default LLM, like what's the LLM that the agent is going to use. So here I'm saying like I want to use a grok LLM, and this is the model, specific model from grok. Temperature, dataset path, like where my dataset is present and like where the model should be stored, which is basically within my artifacts and model, right? So I'm saying this is more of like a telemetry thing in CrewAI. So this is like they kind of collect some data for their feedback and all that. So CrewAI collects that. So this just like disables that. So these are the values that we need. So the reason we are having a .env file is you can put all these API keys, LLM values and everything directly into your code, but it is not advisable. You should never put your secret API keys in the code explicitly, because let's say you put that in your code and when you push that to GitHub, other people can see it, right? So all those secret information should be present in your .env file. And the other main important aspect is this LLM is configurable. if you just like put this inside your code, when you want to change a model, let's say now you want to try OpenAI's GPT model, then you have to go into your code and change this. If you have this in a .env file, you can simply update it here. So all the configurable things, all the things that may change in the future, all these things you can put in the .env file, so that you can easily change this. Say for example, if you want to have a different temperature value, so instead of putting that in the code, if you have it in a .env, you can easily configure this, try experiments with different values instead of like actually editing the code. And you also don't push the env file to GitHub, so it would be like by default it would be ignored, as we have mentioned it in the git ignore file and all that. So it's like there are like a lot of advantages in working with this. And then we have dataset path. Again, you can mention or you can hard code the values in the code, but it's not advisable, so that later if you just move this to a different folder, you can simply update this file instead of making any changes to the training script. And then we have the model path similarly. So when the model is trained, it's going to look for this particular variable and uses this path to save the model. And this is, as I said, it's a simple variable to block telemetry, tracing and everything. So these are the environment variables that we have. So you won't see this .env file in the GitHub repository. As I said, it won't be pushed by default, but I have given this env template. So you have to create your own file. Just like right click here, create a new file and just say .env, and within that copy all this content and just like replace with appropriate values, like your own Grok API key that you can get from Grok console. You can maybe go with Grok is like much faster, and even you can run this with the free tier, so you don't have to provide any card details and all that. So you can try Grok. Temperature values, you can maybe set it to 0.0 itself so that your results are reproducible. The main thing you have to update are your dataset path. So this is the path in my local machine, so you have to update these two paths with your path, like, and your desired directory and all that. Okay, otherwise like the model, temperature and other things, like you can keep it as is. Create your own API key. So for creating the API key, go to Google, search for Grok API key. So you will see this console.grok.com keys. So from that you can simply create a account from your Google account itself, and then you can click on this create API key. From there, like you can just like get that key and paste it in your .env file. So we have this 6x0. So yeah, this is the key that I've created just sometime before, so you can use this. So this is the first step that you have to do. Again, this is like interchangeable. Either create the env file and run the pip install requirements.txt, or you can go the other way around. So these steps are like not related, so that's okay. It's okay, like whatever the order you're doing. Okay, so this is the first step, so configuring all these things. So now I'll just close all these things and just open the readme file and .env. Now I'll explain you about this config. So in all these main directories which I'm going to import, so I'm going to import this config and agents and everything in other pieces of the code. So in those places you can also add a init.py file. So _init_.py. So it kind of now Python treats these as modules or libraries that you would import easily. So that's why you are seeing like this smaller circle over here. So it has this init files. So we have all those things, and within config also we have this init file, which is basically an empty file. You don't have to have anything here. And this is the settings.py file. So here we say that from .env import load.env, and from pydantic settings we are importing this base settings. The reason is when you use this, you don't have to get the values from your environment variables. You can easily get these values from the settings. From the settings.py, you can call this settings class, and from that you can get your API key, your default model, temperature and everything. So it's a more kind of standard and production grade approach of how you would handle these configuration and env variables. So I thought that I could just explain this so that you can follow this approach in your own work as well. So that's about the settings.py that we can have in this config directory, which we will import in other pieces of the code as well. Now I'll come to this MLSRC, which is the first step. So I've created a training script. Again, it's what you would kind of create in a notebook file. So I've just like created the script step by step in a notebook file and just created one simple function. So you can simply run the script. So that's going to do all the steps. So it's going to read the CSV file and it's going to like do a bit of cleanup, replace the missing values and all that, drop the labels, and then it's going to save the labels in other column. Basically what you would do when you train a model. So I'm not going to go detailedly into this because I hope that you already know this. You can simply go through this. It's mainly like data collection. So you just read the data, process that a bit, split the data into training data and test data, and you kind of initiate a random forest classifier. You can use other models as well, but I use random forest classifier. because this diabetes data set is like kind of imbalanced, and it won't give you like a lot of it won't give you like good accuracy. It's not like that good. So I've just like used this random forest because it's kind of not sensitive to imbalanced data set. So that's why I've used this. And we have also kind of do some hyper parameter tuning as well, so that we can get the best model. And finally we save this best model to this artifacts directory. So that's like the whole process of this. So you read the data, process it, train the machine learning model, do a hyperparameter tuning, and save the best model. And this model is stored here. And this is where we are calling the settings. If you remember, we are importing this config. So from config.settings, I'm importing the settings. From that settings, I'm getting the dataset path, model path, and everything, which would come from this env. So this settings.py would read the contents of the env file, and from that we are importing like all these values, and we are passing this to the function called as train diabetes model. So that's the whole idea. And here I've added this 3 lines: system OS libraries are imported, and then we are adding this path. This is basically when you don't do this right. So we are going to import it in other modules, other scripts as well, and it's going to throw you an error saying that I couldn't find this module called as config, or I couldn't find this module called as agents SSE, and so on. So this is going to add this path so that again it's kind of discoverable. This script is discoverable as a module to other scripts. So that's why you can just like in a standard way add all these things to like the main files that you're creating. But yeah, that's about it. That's the whole idea for this. The main objective is, given the configurations of dataset files, model path, and everything, you have to train me a model and save this in the artifacts model directories. That's the idea. So I've already created a model, but I can delete this and I'll show it to you. So I'll delete this. Now once I run the script, it's going to save this model file in this model directory. So right now, as you can see, it doesn't have any files. So now you can come back to this readme, copy this Python MLSRC train diabetes model.py, and you can just paste this in the terminal. So now it's going to train that model. So again, randomized search cross validation is happening. So like all the folds will be done, and we would get a trained model, and I've also printed the accuracies as well. So once we have trained this model, we would create a tool, basically a tool where the agent would give the inputs like the pregnancy value, the BMI, and everything. The ML model would give the prediction, which is basically a tool, right? And agent gets the output from this tool, and then it builds up this explanation, actionable advice, and all that. So that's the whole idea. So it's a very simple process. It may sound complex, but it's very simple. You create a machine learning tool, that is all, based on the model that you're training, and you can simply like integrate that with the agent. Even this can be done for like other data sets as well. So it's not complex. So here we have this ROC values and all that, as this is kind of more of a imbalanced data set, and the accuracy may not kind of be giving you the right picture. So I have printed precision, recall, and F1 score. Again, as I said, it's kind of a bit tougher to get good results with this particular data set, but let's kind of stick with this because the main idea is just to understand this integration of how you can use a ML tool with the AI agent. So let's not focus a lot on this accuracies, but definitely you can spend some time to optimize this a bit. I've also added the hyperparameter tuning and everything, but even you can just like process a data set better and everything. So I haven't kind of spent a lot of attention to that, but you can definitely try that. So we have the model performance, we got the best parameters with this N estimators and all that. And we have the training accuracy, test accuracy, and all those things. And it says that the model is saved to volumes, my drive, and so on. This is basically this path is taken from this .env file that we have mentioned here. So whatever path you mention here, that's the place where the model will be saved. And if I now click on this drop down, I can see the model that has been created now. So this model will be used by the tool that we will be creating. But we need to understand whether the prediction works. So I've created a kind of a testing script. So we are not going to directly use this, but this is the code based on which we are going to create the tool. So it's going to be very similar to the tool code that we have. We would just like kind of call the CrewAI decorator. You will see this, but yeah, the main purpose of this script is to predict whether a person is diabetic or not, given an input dictionary. And this input dictionary would have like pregnancies, glucose, all these values, basically all the values that the model is trained on. Okay. And we have created a function called as predict diabetes, load the configuration settings and so on, because we need to understand where the model is saved, right? So for that we are like importing the settings, loading the settings, putting that in a data frame, and then passing this to the model.predict function and getting the final output as well as the prediction probability, and saying if the value is 1, in that case, like we say it's basically like 0 is like non-diabetic and 1 is diabetic. So we say that label diabetic if prediction class is 1. So basically when the predicted class is 1, you say the person is diabetic. When the class is 0, else condition, you say non-diabetic. So this is the condition, and this is the final output it's going to have. So it's going to have 3 key value pairs: prediction, whether it's 0 or 1, and the label. If it's 0, it's non-diabetic; 1, it's diabetic. So we have that label that we have kind of created over here, and the predicted probability, like what's the probability that the person is going to be diabetic. So we create a float value with this, and this is just like testing this function that we have created. So predict diabetes. So if we have this name is equal to main, so that this gets executed when the script is called. So we have this patient is diabetic with the input values, so you shouldn't miss any of these values. And then you call this predict diabetes, where it's going to process this data and then pass it to the model and finally give you the prediction. So I've taken 2 examples. One is the case where the person is diabetic, and the case where the person is non-diabetic. So if you see this, the person's glucose is a bit high, the BMI is high, age is also, so on, like some factors that could contribute to that. In this case, we have like lesser glucose level, BMI and everything. So you can again, you can run it from here, or you can simply copy this predict diabetes. As I said, it's an optional and test script. So you can copy this command, python ml src predict diabetes.py. So come back to this script, open your terminal and paste it. So it's going to say whether a person is diabetic or not. So this is for the first data point. So, and the second output is from this second data point. So this is how you have to do it. So first we have trained the model, and then we have created a function to predict the model. So based on this code, we are going to create a tool. So let's see how that can be done. So now we can open this agents src. It is like a project structure that you would have for a CrewAI system. So you have a agents folder, you have a task folder and a tools folder, and then crew, which is basically to combine the agents and the task. We only have one agent, but if you are working with multiple agents, you can combine all those things within the crew. And this is just to test like the entire crew. Later, we would call this agents code from our Streamlit app. Let's understand that part. Okay. I'll just open this env file and read me alone to just keep things simple. Okay, so first I'll open my tool. So it is like the diabetes prediction tool. It's basically like almost the same code that we add in our YAML src folder for prediction. Only difference is that I have kind of imported this CrewAI.tools and imported this tool method, tool class or method, like whatever it is, and I'm creating a decorator over this. Okay, so I'm saying like diabetes prediction tool. So when we pass this, it's basically like kind of registering the tool that the agent can use. So later we would say that the agent should use this diabetes prediction tool. So that's the idea of that. It's basically a simple function. We pass the input data, same input data, and the output would give you the prediction label and the probability of the person being diabetic. Same thing that we have developed, nothing complex at all. So it's as simple as that. So you train a model and you create a tool which is mainly a prediction function, which is going to be used by the AI agent. Okay, so this is present within this tools directory. Now you open your agents directory, where we have created this diabetes prediction agents.py. So here we are importing CrewAI's agents and LLM agents. So here we are importing the tool that we have created, and from config.settings we are importing settings because we need the default LLM that it has to use, default temperature and so on. And then we say that the LLM is kind of retrieved from the settings or default LLM, and the temperature value is this. Now, as I said, if you just like hard code your models as in like Grok, Llama 80, 70 billion or 8 billion version, if you do that, if you want to try the OpenAI model, you have to change the code. But if you use this approach, you can simply, instead of saying Grok Llama, you can say OpenAI / GPT-5. You can just simply update that, and that would be a configurable aspect. So you don't have to change anything in the code. So here we are setting up the model that we want to use and initializing the LLM. So this LLM method is class is getting imported from this CrewAI, and then we later pass this LLM to the agent that we are creating. So we are importing this agent class and the LLM class, and this is where we are creating that agent instance. So we are saying the role. So this is the important aspect, the role, goal and backstory. So the role of this agent is diabetes prediction specialist, and in the goal we have to say what we are expecting from it. So we are saying that accurately predict diabetes risk for patients using only the provided prediction tool. If you don't mention that, sometimes the agent can hallucinate and it can just, with its own knowledge, it can say this person can be diabetic or this person is not diabetic. So now when it uses a tool, it's relied on a trained machine learning model which is based on data. So that's why we say that only using provided prediction tool you have to kind of use that, and based on the input data. Additionally, provide clear and actionable health advice tailored to the prediction result. So these are the expectation for us, right? If you want to include some other details, or let's say suggest some other test the patient can take, you can add that to the goal as well. So the agent would suggest that. Backstory is more of persona, and you can say like how you expect the output to be, not the exact goal as we have mentioned here, but it's more of the characteristics of the agent. So if you read this, it says, you are an analytical yet supportive assistant whose purpose is to deliver precise diabetes risk prediction and practical health advice. Your persona is objective and caring, and so on. So it's more of like the characteristic aspect of this. You can go through this. You can refine this a bit if you want as well. It's not like a strict rule that you have to use this exact text. You can improve upon that. And to this LLM parameter, we are passing this LLM instance that we have created. This is the important part. So this is where we are passing the ML tool, the predict diabetes tool that we have created. So we have this diabetes prediction tool within this tools directory, right? And then we have a function called as predict diabetes that we are importing in this line number 3. So that we are passing to this tools list. And even you can just like create multiple tools with multiple disease prediction ML models as well. But yeah, in this case, we are just considering one example, but you can do that as well. Verbose is equal to true. It's going to just display the intermediate results and so on. So this is the agent code, and tasks is like pretty simple. So we are creating a corresponding task that the agent has to do, which is diabetes prediction task. And the main important aspect here is we are importing this particular thing. Why this is not on top? Let me just change this. Okay. Yeah, so we have created an agent, right? So that agent should be imported in this particular task called as diabetes prediction task. And this is like you can also say that this is the exact output structure that I want. If you don't do that right, one time a model would give you the explanation and one time it may not give you the explanation. So we strictly say that you have to follow this pydantic based model. So this is the final output. So the final output should contain these 4 aspects: diabetes risk prediction, which is of this type, diabetes risk prediction, which in turn would contains the result, probability diabetic, and test result language. Again, it might seem a bit complex right now, but once you see the result, it would be like clear to you. Yeah, it's not right now here. I'll show this to you. So basically the idea is this is the exact output structured way I want my output to be. So first is this object which has result, probability, and test result, and then I want a list of explanation, and then actionable health advice, which is also a list of string, and then a tool output. Tool output is the raw tool output. We are saying that it can be like any data type and so on. And this is again an important part of how you define your task and expected output. So we say predict the risk of diabetes for a patient using the following input data. Input data is patient data, which is going to be getting flown from this main.py. So it would be propagated from this main.py. If you open this, we would pass this pregnancy, glucose, and so on in a dictionary called as patient data. Within this key called as again patient data. So that would be replaced in this task description in the runtime. So now the agent looks at all these patient data and calls this tool and push all this data to that tool, and the tool would give the output, and finally it would come up with like the risk factor, the explanation, and the actionable health advice, and so on. And here we say that the expected output is this: a Python dictionary format with the following structure. So it should have this diabetes risk prediction. So these are the 4 keys: diabetes risk prediction, explanation, actionable health advice, and tool output. This diabetes risk prediction is in turn a dictionary. So this is what we are defining here as well. So here we have defined it as a pydantic based model. Here we are explaining in natural language so that the model LLM can understand. So you say that these are the outputs that I'm looking for. And we also have a parameter called as output pydantic, where you mention the output structure, and the LLM would kind of stick to that and would give you output only in this structure. And finally, we have to pass the agent that we have created in this agent parameter. So we have imported this agent from this agents src agents directory. So we would pass that. That is pretty much it. Now you open your crew.py file. This is the order. You first create a tool, then create an agent, and then create a task, and then finally stitch that together in your crew. So from CrewAI, I'm importing this crew class, And from this agents directory, I'm importing this diabetes prediction agent. Similarly, from task directory, I'm importing this prediction diabetes task, and I'm creating a crew called as diabetes prediction crew. And we have two parameters, two main parameters, agents and tasks. So this is a list where you mention all the agents that you have, and here you mention all the tasks that you have. If you have two agents, you can just put a comma here, and then you can just like add another agent over here as well. So yeah, that's about it. And verbose, as I said, it's for like intermediate outputs and all that. Finally, you would call this crew from your main.py file. So this is all about defining your agents, defining your task, and defining your crew. But this is the place where your crew is going to be called. So again, this is just about that import part. So this is not that important for us. So we are importing the settings and then like importing this diabetes prediction crew, and we are creating a function called as run. And the input for this function is patient data that we would send from this place. Okay, and I'm saying that crew, which is diabetes prediction crew dot kickoff. This is the important function that you have. This is the function. Kickoff is the function that's going to start this crew, which basically means it's going to call the agent, perform the task, give the input output, and basically do everything. Inputs is this patient data. So whatever you mentioned in curly braces is basically the input for your task or the input for your agent. So this input should come from your crew.kickoff. You see this patient data, right? This is what this patient data is basically this, right? So don't confuse with the names. Whatever things that you're mentioning in this curly braces would be given as a key value pair over here. Okay, so now if you just like think about this, right? So we have a patient diabetic. In runtime, the input would go something like this. So you would have a dictionary, and this dictionary would have a key called as patient data, and this patient data would have another dictionary, which is this. Okay, so when the screw.kickoff is called, this patient data is what the task is expecting. So this patient data, not this one, this is just like string. Whatever you mention within the curly braces, that is considered as a variable. So this patient data, which is a variable, would be replaced by the input data that you are giving here. So this value would be passed on to this variable in runtime. I'll show that to you when the crew is called, so that would make more sense. But just now remember that. So whatever you mention in the task in curly braces, that should be passed on in your crew.kickoff within this inputs parameter as a dictionary with some key value pairs in it. And then you finally print the result as well. And we are testing it for two items. So we are calling this run command twice. If you just want to test it only for diabetic person or like non-diabetic person, you can just like simply comment this line number 41. But let's say we want to test it for both of these things. So come back to your readme, and yeah, so agents src main.py file. So I'll come back here to main.py file, and I can run this. Again, this is not going to be used directly. So based on this code, we are going to call this kickoff from the Streamlit app. So that's the only difference. So clear this, and I'll paste this Python agents src main.py. You may get some errors if you kind of wrongly have the project structure or the path is not correctly present. So just like look out for that. So now I'll call this. So now this crew will be called, which is this diabetes prediction crew, and you will see like all the input and output and so on. So here the agent is diabetes prediction specialist. This is what we have mentioned over here, diabetes prediction specialist in the role. And then we have this task, right? Predict the risk of diabetes for a patient using the following input data, and input data is patient data. Now this description, this task is basically the description that we have defined over here. You can see this exact text that is present here. Only difference is this patient data is now replaced by this dictionary, which we have passed in this main.py file. This is what I was talking about. So in runtime, this variable that you have mentioned within curly braces, whatever you mention in your curly braces is a variable, and you have to pass that variable in this inputs dictionary. Okay, and this task would take it from there, and then it's the agent is thinking, I need to use the diabetes prediction tool because we have provided it with the tool, right? And this is the input data it's going to pass to the tool. So we don't have to manually say that you have to pass this or that. So the agent automatically goes through the tool. It understands how the tool expects the input to be. Say for example, pregnancies is int, glucose is float, and so on. If the pregnancies is float, even if we give it as an integer, the agent is smart enough to convert that into a float and then send that. So it's not a manual step. So and that's the important step of why you have to be very clear with the doc strings that you have, input output arguments and the output results and so on. So then only the agent knows like this is the input structure that I sent and this is the output structure that I expect. Say for example, usually we would skip these parameters. This is just saying that the input data is a dictionary and the output data that is coming out of this function is a dictionary. So all those are defined here. We won't use this generally when we code, but when you are creating a tool, you have to do this because then only the agent understand the input and output structures and it would efficiently use the tool. So this is the tool input that the agent is sending, and this is the final output that the agent is kind of receiving. So this is for the first input that we have sent. Okay, and finally it gives this answer. So if you now come back to your task, you can see the pydantic output structure that we have defined. So it should have 4 key value pairs: diabetes risk prediction, explanation, actionable health advice, and the raw tool output. So you see like all those 4 key value pairs, and this diabetes risk prediction in turn is a object of type diabetes prediction, which is result probability and test result in natural language. Basically what the test result is, whether the person has a risk of diabetes or not. So this is like the exact input and output I'm expecting. So this is the reason we are defining the pydantic structure and passing this to the variable called as output pydantic and explaining it in the expected output. So this is the entire purpose, and finally you print that output over here. Okay, so yeah, this is where it's getting printed in the crew output format. So this is coming from this line number print result. So we have this run function which takes in this patient data. So this run function is called twice. One is for the diabetic patient's data, and one for non-diabetic data. So we are calling this function, just printing this hyphen just to separate these two crews. So until this part, it's like the first patient's data, and then we call the second patient data, which would probably say like non-diabetic. Now if you see the tool output, it says like the label is 0, the person is non-diabetic, probability is very less, 0.02 for them to be diabetic. So we get the final answer, and then it would give you the explanations of like, the glucose level is within normal. So it gives the explanation, and it says that maintain a healthy diet to keep glucose level in check, engage in regular physical activity, and so on. And it also gives you the tool output so that you can be sure of what's the exact outputs that's coming from the model. So this is the entire process. That is pretty much it. That is the pretty much the entire idea of this backend. And again, let me not go in detail about the Streamlit code because it's pretty simple. You can go through this, but the main brain of this application is this CrewAI systems and the ML thing that we have built. So I'll open the Streamlit SRC. Yeah, so all these are just like, you may see a lot of code, but it's more of like formatting. So you see there's like vertical columns and so on. And maybe I'll show this to you, it would be better. So these are the steps. So first, yeah, install the libraries, create your env files, train your model, test whether the prediction script is running, and test your crew. And finally you can start your Streamlit app, which is present in the Streamlit SRC app.py. So you come back to your script, open your terminal, and then paste this Streamlit run Streamlit SRC app.py. So this is automatically going to open your localhost 8501 is the port that it's running. We are using Grok, so even you can actually deploy this on Streamlit Cloud as well, because this doesn't require a lot of resources. So even you can try this and you can share it with your friends as well. Okay, so now let's understand this code quickly. So we are importing Streamlit and setting the page config. So page title is diabetes risk prediction, and the icon is a simple pill icon, and layout is centered. So you see this layout is in the centered place, right? So that's the layout, and you see this name page title, which is diabetes risk prediction, and a pill symbol over here. So those things we are configuring it over here, and the title, and we are saying like enter patient data to predict diabetes risk title, and this text, which is kind of creating these two lines. And now we are creating this box where the user kind of gives their value. So we are creating st.form patient form. Okay, so if you come back over here, this is the form where we are going to get all this input. So we say that column 1, column 2, column 3. So we have to create 3 columns. This columns is nothing but, you see the pregnancies, glucose, blood pressure here, skin thickness, insulin, BMI here. So it's basically 3 columns, right? So that's what we are defining over here. Instead of having it line by line, it looks better. So that's why we have it over here. Yeah. So if we come back, so we get the user input, number input, and all that. So yeah, so if you just like look at this, okay, let me open this. So all these are like number inputs. So we can kind of edit this with this plus or minus, or we can just like, yeah, simply type it like, that's the whole idea. And then finally we have this predict function. Let's come back over here. Okay, so pregnancy is glucose and so on. So we get the input value from the user. We also set like a default value so that you can simply test it out quickly. And then submitted is equal to st.form submit button. So this is the form submit button. So we are naming this button as predict. You can give any name. So basically this form is this widget that you're seeing. You see this box, right, where the user submits this data. So this is created using this patient form thing. So form thing, and then we created button using form submit button. So once it's submitted, once the patient clicks on submit, we gather all this data into a dictionary, and then we pass this to the crew that we have created. Same thing that we did with main. Okay, so diabetes prediction crew.kickoff. So we have imported this crew from this agents src.crew. We do all those things, and then finally we print all this result, explanation, prediction probability, summary, and everything in a more structured way. So it's not complex. And finally we have a expander, where if you click on the drop down, your tool output is going to be expanded. By default it won't be expanded. So that's the idea. Again, it's just like a simple display thing. It's similar to a print statement, but only difference is that we are going to structure this in a proper way. So let's come back here. So let's say that the user has given some default values, or they can also change it. And once you click this form submit button, so your crew is going to be invoked, and we pass all this data to the agent, and in turn it would call the tool, and it says, it gives the final response. So this input negative 0.02, all these are coming from that tool output based on which the agent has created it. And this is the summary and the explanation, actionable inputs, and finally you see the raw tool output. All these outputs, negative, 0.02, summary, explanation, all these are coming from the crew that we have created. You can open your terminal, it would show the output. This is the agent output, right? So first you have this diabetes risk prediction, result, probability, and test result in natural language. These three things are the ones that are displayed here. So your result, your probability, and your natural language, so that it's easy to read for a user to understand like what's the result is. And then you have explanation, actionable. These two are list which are coming from here, your explanation and actionable health advice. So we are just like displaying it in proper tables. So that's why you are using this somewhere here. Yeah, st.table, so that it's present neatly in a table. And finally tool output is present within a expander. So by default it won't be visible. So you can just like click on this tool output, you would see this. So this is the entire idea of this. So this is how you can actually kind of create a machine learning tool and simply integrate with the agent. So I hope that you understand this entire process. Try this out. If you face any errors, please let me know. I'll try to kind of help you with that. And yeah, I'll just give you a quick recap or the order of things that we have to do. So first thing is create your env file, create your grok API key, install your required libraries. Then you can train your model by running this ML SRC train diabetes model. So now you have a trained model. You can test it with running the predict diabetes function, and then run the main crew by using this agents SRC main.py file. And then finally you can launch your Streamlit app, and then yeah, you will see this particular output on your screen. So this is the entire part. So I hope that this project is exciting for you. So I'm curious of how you're going to use this and build other projects. So this is not just like a one-off diabetes prediction app. This is more of a template that you can use in order to create more exciting, more innovative applications by using, let's say, a deep learning model or ML model and so on. So please try that out. Let me know in the comments of like the things that you are thinking about building, or you can let me know in the comments of what other projects you want to see. So yeah, that is all from my side. Thanks a lot for watching. So please check out my generative AI course on Udemy. So if it sounds interesting, so you can sign up. Yeah, let's see in the next video. Thanks for watching.